Alright, welcome back guys. We're going to go ahead and finish up section 2.2 on functions and graphing. So, previously we looked at actually defining what a function was. You just have to remember that for every input there can only be one output. And we don't care what that output is. Okay. We also talked about that the domain is basically the set of all the inputs, and that the range is the set of all the outputs. So again, think about that analogy that I used of a juice maker. The inputs would be all the different fruits that can be juiced, and then the outputs would be all the different types of juices. Okay. And then furthermore, we also looked at evaluating functions. So we had actually already been doing this. And this just involved inputting values in for the independent variable and seeing what those outputs were. Or in other words, those outputs are the value of the function, okay, for those specific inputs. All right, so to finish up this section, we're going to get a couple more examples in graphing functions. So let's go ahead and do that. So let me zoom in a bit here. So this function here, guys, we want to graph it. Recall too, though, that previously we expressed this as y equals negative x squared plus 5. But now we're going to express it in terms of a function. We're going to call it h of x is equal to negative x squared plus 5. Okay, so h is just the name of the function, and the x here in parentheses just shows that the value of this function depends on x. And so to graph it, what I did is I just went ahead and generated some different values of x, symmetric though with respect to 0. And remember too, when you're graphing these, you want that first point when you go to plot these in your homework to be the center of that parabola. Okay, so I can tell just by looking at this function, and we'll talk more about that later, but the value of x being 0 is where this function is going to be centered. And so I just chose a couple values to the left and a couple values to the right on the x-axis. Okay. I do want to do a couple of these by hand. So I'll start with the negative 2. So I'm just going to plug negative 2 in for x, but remember the negative sign is already in front, and then I plug in my negative 2 and I square it, and I'll say plus 5. Because when you square a negative, you get a positive. And so negative 2 squared like this is 4. And then this negative that was part of the function will turn it into negative 4. And then we'll still have that plus 5. And then this is going to give us a positive 1. Okay. So guys, you're doing these the same way. And I think maybe that's all I'll do. I think I'll refer to my calculator and the table in the calculator to find the rest of those function values. So I'll go to y equals, remember this is negative x squared plus 5. Square it, and we'll say plus 5. I'll go to the table, and for some reason I'm way up in the... Alright, so here we go. Alright, so you can see negative 2 comma 1 is confirmed. Now when x is negative 1, the value of the function is 4. Remember the value of the function is the same as the y coordinate. And then we get these others. These other outputs are going to be 5, 4, and 1. So I'll just copy these down. Okay. 0, 5, 1, 4, and 2, 1. Alright, so I'll do this one the same way. I am going to start with the center point. Again, guys, if you're unsure how the function's going to look, just go ahead and graph it in your calculator. Okay, see that? So you can see the center point is whenever x is 0. So if I were graphing these by hand, or not by hand, but in the software, that's the first point that I would plot. And then I would need one or two other points just to fix the shape. Okay. All right. So 0, 5 is going to be here. Negative 1, 4 to the left 1 and then up 4. So this parabola is actually upside down. Negative 2, 1 is going to be right here. And then on the other side, 1, 4 to the right 1 up 4. And finally 2, 1 is right there. Okay, so now if I connect these, we can see that this parabola is upside down. And again, let me just reiterate that this is a quadratic function because it's got an x squared in it. The reason it's upside down, guys, is because of this negative. What that negative is doing is, for the most part, it's making all those outputs negative. When you add 5, some of them will be positive. That's why it's above the x-axis here. But most of them are going to be negative. That's why it dives down on both sides. Let me show you something else real quick. Hey Rachel, hold on just. Alright guys, yeah, I did want to show you something else. So, actually a student, I guess, maybe about 5 years ago, showed me this website. So it's called Desmos, DESMOS.com. And so all you have to do is type in your function. And the nice thing about this is you'll get a much more detailed picture of the graph. Alright, so I'm going to type in wait. There we go. Y equals negative x. And then you'll have to hit the caret key and then square it and then say +5. And so it graphs it. And so this would be an easy way to find some points as well. You can see where it crosses the x-axis. We'll be talking more about this later on. But anyway, this is kind of a neat website for you to look at if you want. Anyway,
and so I was going to have a conversation with Valerie. Yes, see if we could knock it out of more efficient. So do you have a
alright, so now we'll look at example 6. So example 6, guys, just another type of cubic function. Okay, and remember, when you're graphing these in your homework, that you're selecting the correct graphing tool. So if it's a quadratic function, you need the quadratic tool. If it's a cubic function, you need the cubic tool. Okay. So you can see here that I've chosen the same values for x. Now I do want to point out, guys, technically it doesn't matter what values of x that we choose, right? It's just, again, that I can see this guy's going to be kind of centered at around the origin, or where when x is 0, and so I've just kind of chosen values around that. If this function had been shifted to the left or to the right, then these values might not give me a real great picture of the function. But anyway, alright, so I will do one of these by hand again. So let's plug in -2. So, you know, the name of this function is h of x. So essentially what we want to do is find h of -2. In other words, what's the value of the function when x is -2? Okay, so plug -2 in, except this time we're cubing it, and then we're going to subtract 3. The thing is that when you cube a negative, you actually get another negative. And when you cube -2, you're going to get -8. And -8 minus 3 is -11. And will actually be off the screen, or off of our viewing window just a little bit. Okay, so that's one ordered pair, and then we can find our other ordered pairs using our table. And guys, I'm sure there are a plethora of resources online, graphing tools and other software, free software that you can use to create tables or anyway. But all right, I'll go ahead and input this function. It's x cubed. Make sure you move your cursor outside of that exponent, and then say -3, and then go to your table. All right, so we can see when x is -1, y is going to be -4, and then -3, and then -2, and 5. -4, -3, -2, and then 5. Okay, so I'll turn these into ordered pairs. Alright, and then I'll go ahead and start plotting them. So -2, -11, this is just going to be off the screen by 1 unit, or off the viewing window by 1 unit. And then -1, -4 is going to be down here. 0, -3 will be here. 1, -2 right here, and finally 2, 5 is going to be up here. So again, we have sort of that undulating behavior. This function is actually increasing. It increases. That just means that if I plug in successively larger values of x, that those values of y will increase. Each one will be greater than the other one. And so if you're looking at these values of x as they're increasing here, look at what these values of y are doing. They're actually increasing as well. Okay, going from -11, then to -4, which is a bigger number, then to -3, then we start getting into the positives. Alright, and then, if you wanted to look at this with Desmos, you could. So what is it? -3. Okay, there it is. And you can, nice thing with Desmos is you can zoom out, and you can zoom in pretty easily just with your mouse, or the scroll wheel on your mouse if you have one. Or you can really zoom in. This is a really nice feature here. So if I was trying to figure out or get a good approximation of where this function crosses the x-axis, I could just keep zooming in and zooming in and zooming in. Your calculator will do that as well. It's just not as pretty as it looks here in Desmos. Alright, so let's go to the last little subsection here. Okay, so we've looked at some relations up here at the beginning in determining, here these were some examples. These were very simple relations, guys. They gave us a domain and a range, and the arrows showed us how those elements from those two sets were related. And so we had to figure out whether these relations were functions or not. Well, what if we had an equation that was already graphed for us? That's what we're getting to now. Okay. So if we already have a mathematical relationship, and that relationship has already been graphed, and again, the way you would do that is by collecting a whole bunch of ordered pairs, plotting them, and then connecting the dots, and then you get a different shapes for the different mathematical relationships. And so how do we actually determine, just by looking at the shape of the graph, whether that mathematical relation is that of a function? Okay. And one easy way to do this is by using what's called the vertical line test. So what has to happen, guys, is for each value of x, there can only be one corresponding value of y. We don't care what the value of y is. But if there are ever two values of y, then that relationship would not be a function. And so the vertical line test is a nice way to, or is an easy way to figure that out. And so basically what you do is let's look at example A right here. Or actually, you know what? Let's look at this example. Is you think about an imaginary vertical line and you just place it anywhere on the graph of the relation. And if it ever crosses the graph of the relation more than once, so for example, if I put actually let me draw this with my stylus here, so let's see if I can do a better job. If I arbitrarily choose to put a vertical line here, okay, then you can see this vertical line is actually crossing the graph of this mathematical relation in three different places. And what this means is these three different points, you can see these three different points, they all have x values of 3, okay? So that one value of x is actually corresponding to three different y values because there's three different points. So this is really what we have happening. We have that one value of 3 corresponding to 5, corresponding to 2, and also corresponding to -1, okay? And so that's why this is not the graph of a function. Now this is still a mathematical relationship. The values of x are still related to values of y. It's just that for any given value of x, there are certain values of x that are related to more than one value of y. Okay, and that's what makes it not a function. And that's why this vertical line test works. Okay, so let's look at A. So obviously A is not going to be a function, right? It's not going to be the graph of a function because if I put a vertical line right here, then it intersects the graph of that relation in three places. So we're going to say that the graph of this relation is not a function. Okay, what about part B? Well, you could actually know the answer to this one without even using the vertical line test, because that's a graph of a parabola. And we know that a parabola comes from a quadratic function. So we know beforehand that this is already a function because we were studying or discussing quadratic functions. But in any case, guys, if I think about a vertical line, placing a vertical line anywhere on the graph, it's only going to intersect the graph of this relation in one place, okay? Regardless of where I put it. And that just means that for any given value of x, there will only exist one value for y, okay, or one output, essentially. Think back to the juice maker, okay? You can't put one specific type of fruit in the juice maker and then get two different types of juice, right? I cannot put a grapefruit in and then get both grapefruit juice and grape juice, okay? So one input, one output. All right, so this one is a function. All right. Okay. All right. So with that, guys, that concludes section 2.2. Section 2.3, we're going to study the domain and the range in more detail. Okay. And we'll be discussing that a lot throughout the semester as it pertains to functions. Every single function, guys, is going to have a domain. Most of the functions that we've studied thus far, the domain of those functions would be all real numbers. And all that means is that any value of x would work. You could plug any value of x into the function, you would always get an output. But that's not the case for all functions. There are certain functions that there are certain values of x that just simply will not work. Okay? They will not give us an output. Think about the juice maker, for example. If you're trying to make juice, you can only input fruits, right? And potentially only certain kinds of fruits. You couldn't input things like books or, other types of objects. Those are not going to produce anything. You're not going to get any output. In fact, they'll tear up your juice maker, right? So anyway, all right, well, I'll see you in section 2.3.